Okay, 4.2, we're adding that natural base e that we learned about in the last section to functions. So this is a basic exponential function where x is the variable in the exponent, but now our base is e. And we talk about these functions when we talk about exponential growth and decay. So we're focused on r, that's the rate. If r is greater than 0, we have a growth function. If r is less than 0, we have a decay function. And then a is our starting value. So that stays the same. But let's see. Here's our functions when they're graphed. So growth, look from left to right. From left, it's going up. And then left to right, if it's negative x, it's decay. It's going down. So that depends on what your r is. Is your r greater than 0 or less than 0? And then also, I want you to notice that these functions have what we call asymptotes, which we've learned about before, along the axis. So y equals 0 is the asymptote. That means it gets really, really close to 0, but is never actually 0. Okay, so you're in this section, you're going to be examining rate. Is it growth? Is it decay? You can tell by looking at the formula. A is also our y-intercept. And we see that when we look at compound interest. So when interest is compounded continuously, A is in the account after t years. So A is our ending amount. P is what we call the principal. It's the initial value that you put in the bank account. R is the interest rate. And T is time in years. So we use this type of formula for growth and decay, for interest, for anything that grows or decays continuously. And you need to know the parts of that formula.